Hello students, today we will be studying about organometallic chemistry, and in organometallic chemistry first of all we will study 18 electron rule. So this very first topic is very important for our main topic, that is organometallic chemistry. So first, before we talking about 18 electron rule, let us first know what is the purpose of this topic or purpose of this rule. So the aim of this topic is to explain the stability of the complexes of metals. Means if we have metal complex, we want to know about whether it is stable or not, then we need 18 electron rule for this purpose. Before this 18 electron rule, there was a rule called electron atomic number. Sorry, effective atomic number rule. So what this rule says, it says the sum of electrons on the metal plus electron denoted from the ligands are called effective atomic number. Means the number of electron that is given by the metal, means its outermost shell electron plus the electron given by ligands makes effective atomic number. If it comes to be equal to the configuration of the noble gas, like 36 for krypton, 54 for xenon, or any other further noble gas configuration, then this rule was said to be obeyed. So this was also a method, and this was the method to determine the stability of the metal complex. But nowadays 18 electron rule has come to play. So what this 18 electron rule says, it says when the metal achieves an outer shell configuration of ns2 n minus d10 np6, there will be 18 electron in the valence orbitals and a closed stable configuration. So we can say that 18 electron rule is more convenient than the previous one, that was effective atomic number, because here we don't need to know all these configurations of noble gases. So what are the advantage of 18 electron rule over EAN? It is more general statement or rule over EAN. Also, it is the same for all rows of periodic table, eliminating the need to remember a different effective atomic number for each noble gas. So that is the advantage of 18 electron rule over effective atomic number. So now we will see the examples for this rule. First is chromium complex, where chromium is forming the complex with carbonyl group. So you can see chromium has 6 electrons in outermost shell, and every carbonyl group and gives 2 electron. So 6 into 2 is equal to 12, and total we have 18 electrons in the outermost shell. So this complex will be stable one. Also, in second example, we can see that iron is making a complex with carbonyl group and phosphine group, and each carbon has 18 electron in its outermost shell, or you can say and 2 electrons each for carbonyl group and 2 electron each for phosphine group. So we have total in 18 electrons. So it is fulfilling our need for 18 electrons in outermost shell. This is also a stable complex. Now we have different ligands contributions to electron counting. First of all, we have carbonyl. Carbonyl also gives 2 electron. Thiocarbonyl, where metal is connected with carbon and sulfur, it also gives 2 electrons. Phosphine also give 2 electrons. Amine also give 2 electrons. Then dinitrogen and dihydrogen also gives 2 electrons. So this was the 18 electron rule. I hope you will understand well, and thank you.